So the last quadrilateral we're going to spend a bit of time on is called a trapezoid. So a trapezoid has exactly one pair of parallel sides. So what makes this different, let's try that again. What makes this different than a parallelogram is that a parallelogram had to have both sides parallel. A trapezoid only has one set of parallel sides. All right. Now, when we look at a trapezoid, sometimes the questions are going to be about this line that divides the trapezoid. This is called a median. All right. And the way we draw a median is to connect the midpoints of each of the sides. So if I'm over on this side and I know that this is the midpoint, and then I come over here and I know this is the midpoint, then I've just drawn the median in. And so if I wanted to find the length of a median, it's half of the two bases added together. So some of the vocabulary that we talked about with the trapezoid already is that the two non-parallel sides are called the legs. So this is a leg and this is a leg. And the two parallel sides are called the bases. All right. Now, if I also wanted to talk a little bit about an isosceles trapezoid, remember we learned in triangles that an isosceles trapezoid means, or an isosceles triangle is a triangle that has two congruent sides. Well, an isosceles trapezoid means the legs are congruent. Okay. So just like what we did with our parallelograms, 1 and 2 for my isosceles trapezoid are actually the same. So if I look here, 1 and 2 are the same. So exactly one pair of parallel sides, and the median is 1/2 base 1 plus base 2. So this would be my base 1, that would be my base 2. Now, the trick to isosceles is the legs are congruent. And just by looking at this picture, we actually can kind of see here that the diagonals are congruent too. And then if we remember with our isosceles triangles, we knew that if these sides were congruent, then these angles also had to be congruent. Same thing with an isosceles trapezoid. So with an isosceles trapezoid, if these legs are congruent, then this angle has to be congruent to this angle. And also this angle has to match up to that angle. So we call those our base angles, and those are also congruent. Okay, so if I was looking at this picture here to find the value of x, I see an angle that looks obtuse and an angle that looks acute, and I know I have these parallel lines. Well, that tells me those two angles are consecutive interior angles. So consecutive interior angles from our parallel lines mean that the angles are going to add up to 180, meaning they are supplementary to one another. So for our example 1, I'm going to have a 12x plus 3 plus 13x plus 2 equals to 180. All right, so when we solve this, remember we do have to combine our like terms on this side. So with 12x plus a 13x would give me 25x plus 5 equals 180. And so I would get 25x equals 175. So x would have to be 7. All right, and that one's done. Now, example 2, we're just going to skip it. So you guys actually can just draw a line through it. We are not going to get into all of that long distance. All right, so let's go ahead and jump right to 3. So in example 3, it says this is an isosceles trapezoid. So remember with an isosceles trapezoid, I know the legs are going to be congruent to one another. So if I have EDO, so EDO, so that's this angle here is 110, all right? Find the measure of DEN. So DEN, oh, nope, they told us DEN is going to be a 15x plus 5 minus 5, and I want to find the value of x. So for our example 3, we ask ourselves exactly what we were talking about in this one, right? Those angles, one is obtuse, one is acute. So I'm going to go ahead and add those up to equal 180 degrees. So 15x minus or plus 105 equals 180. So 15x equals 75. So x equals, and if we divide a 75 by 15, we're going to get a 5. Okay, all right. And so then let's just go ahead and look at this last problem here. Another isosceles trapezoid where PR, so that's this diagonal, is 3x minus 7, and TA is 20. Well, if we go ahead and we look at this property 4 here, we know in an isosceles trapezoid diagonals are congruent. So we actually just get to set those equal to each other. So 3x equals 27, so x is 9. So you guys, that is actually our last lesson on quadrilaterals. All right. So we learned quadrilaterals were just four-sided figures where the angles always add up to 360. Then we learned special quadrilaterals. So the first one was parallelogram. And in parallelograms, we know that there are rectangles, rhombuses, and squares. And then we learned trapezoid as another quadrilateral that is not a parallelogram. So this is not a parallelogram, all right? And the reason for that is because a parallelogram has to have the two sets of parallel sides, and we don't have that when we do trapezoids, okay? So we're gonna do more practice with this together tomorrow. Make sure you write down these notes and submit them onto Canvas for me. And have a good rest of your day.